I guess we can start. So, yeah, feel free to, let me introduce myself and then maybe you can take ahead. Go ahead. So, hi guys, my name is Talib. You know me by the nickname Totus. I'm a developer at Citrea. As you know, we've been building for so long, and we have testnet coming up in the next weeks, let's say. And Yeah, so during this period, we're looking for great people to work with, great people to partner with, and definitely one of them is Envio, I would say. They're building a super cool indexer, which I also tried and pretty much satisfied. Um, like Denim will talk about in detail more than me, but overall, I'm keen to learn more and keen to how can we use this more and more in the future.
Cool. Yeah, thanks for boosting the Envio horn. Excited to tell you a little bit more about it. If you read the chat, you'll see I'm from Cape Town, South Africa. I'm currently sitting here. I'll tell you a little bit more with my presentation, but I have been working in the blockchain space for a couple of years, and I can essentially share the journey of how we got into building Envio and why it's such a fantastic tool for developers building on Citrea. Cool, evident. I see another Africa represent. All right, I'm going to share my screen and we can kick things off. But just a little breakdown. If you have any questions, please do feel free to ping in the channel and don't worry about interrupting. If we miss it, I'm sure we can come back to it. I'm going to tell you a little bit about Envio, a little bit about myself, and then we're going to do a little bit more of a hands-on kind of workshop on getting data and what that can look like. It is a little bit developer focused, so we will pull out a little bit of code, but again, these intervals will be quite short, and most of the time we're just chatting more concepts. So if you don't have a developer background, that's not the end of the world. It should be fairly all right. Cool. Let me share my screen. Just want to make sure I'm sharing the right screen. All right. Can everyone see my screen? Can I get a thumbs up? I will take that as a yes. Cool. Let's jump into the slideshow. Cool. So what I'm going to chat about today is how to index data on Citrea in under 5 minutes. And I think what's pretty cool is that 5 minutes is actually a lot shorter, and we're gonna take a look at that. This slide, if it doesn't make too much sense, it's a bit of a kind of brag slide, and we're going to unpack it a little bit more. But it's just essentially showing how much materially faster Envio is at getting data for layman terms. Sweet. A little bit about myself. My name is Denim, pronounced like the jeans. I'm one of the co-founders of Envio. I'm a believer in the tech and not the hype. My academic background is in computer science and economics, kind of the intersection there. Very applicable in the blockchain world. I'm an anarchist at heart, and I'm a couple of those other things below. And I actually got into the space in 2019, attending one of the ETH Global hackathons. And that was kind of what kicked off my adventure. And I'll tell you a little bit more about some of my team members. But also worth noting, in the space, I'm a Pooly holder, I'm a Groundsdale member, and maybe more notably, I'm a Safe Guardian. So I am a delegate and vote on Gnosis Safe, or just Safe now, governance. I am going to fly through one or two slides, just a little bit of background more to us. I say this to add credibility, so sorry if it comes across like a little bit trying to brag, but we've worked with a lot of awesome projects like this that you can see. And I think something that kind of stands out is some of the production systems we've designed, deployed, and architectured have handled well over $75 million in value, and thankfully haven't been hacked. So quite a deep set of developer experience. The team, we are a team of 12 10 technical, 10 developers. We've also kind of dabbled with a couple other ventures ourselves, playing around with different projects and really just tinkering. I think also notably taking part in tons of different hackathons, I think is always a fantastic place to learn. Then also just spoken at a couple different conferences around the world. Cool. But most importantly, by builders for builders. Cool. So I want to start with the story. We were working on a project called Float, and Float was this DeFi protocol, peer-to-peer derivatives, kind of trading different asset classes. And we were using subgraphs for our data indexing. So we were using this kind of layer for getting our data. And after about a year in production, it would take about a week for our subgraph to deploy. And this was a little bit stressful and a little bit scary for us. And what happens if something goes down and you've got to wait a week to kind of redeploy the software? There's financial positions at stake. And so, there's quite a lot of importance or value riding on top of this. And we were relying on it to be reliable. Anyway, eventually we decided to build it for ourselves. And we took the first steps of building our own custom indexer. We felt it was materially better and started generalizing this so that other developers, chat devs, could use it too. Okay, coming back to the slide. As you can see, just a comparison across some of our competitors, something that would take almost 17 hours with subgraphs takes just around 10 minutes with Envio. So kind of well factors or developer experience improvements. Just to make that a little bit more tangible, the 1 week deployment time we were taking with subgraphs with Float turned into 1.6 hours. So it is streaks kind of more performance and speed, and we'll unpack a little bit how we get to that and go through some cool examples of seeing it live too. Cool. I just want to chat about kind of what is indexing first. Like, what are we actually doing here? What is Envio and how does it fit into Citrea? And it kind of ties into kind of data indexing flow, and I'll unpack this diagram. But essentially, an indexer sits between your smart contracts and your front end, or whatever kind of app you've got on top. And it's what aggregates all this information and then presents it to your front end. And if we look at a flow of a kind of an interaction, how this might look with a indexer, we've got a user, they perform a transaction on the chain into a smart contract. This smart contract will perform some logic and usually emit an event. And events are kind of your way of presenting data off chain. Then our data indexer kind of processes this event and it stores aggregated data as kind of information into a database. And then on top of that, we have a GraphQL API, which is essentially like an interface for your front end can get this data from. And yeah, maybe it would be fitting to have another column there for the front end, because that's essentially where the data is coming from. Cool. So again, just want to emphasize, we are kind of the layer between your smart contracts and your front end. There we go. It popped up. Cool. What is an event? Events are smart contract developers' ways of taking on-chain data and emitting it off-chain. There's other ways of doing it on-chain, but it becomes really expensive and it's not the most optimal way of managing data. So working with events in your contracts is kind of a good way to do this. Cool. I think it would actually be quite cool to see this in action, but this kind of token, we have a template that allows you to index kind of tokens, and we can spin through an actual example of seeing that live. But one classic case is that the name and symbol for an ERC20 token, part of the standard was never emitted in events. So in order to get the name and symbol, you've got to look at contract state. And this has been quite a kind of challenge for a lot of people trying to index different tokens, different data. It becomes quite cumbersome. All right, and let's tie this into Envio a little bit more. give you a bit more of a holistic view into what is Envio. So we are a sub-second latency and sync speed optimized blockchain indexer. It's quite a mouthful. But we are kind of the way of accessing real-time or historical data. You'll use our tooling to get data, essentially. Cool. And as I've touched on and maybe shown the slide one too many times, it's blazingly fast. All right. Want to kind of unpack another concept here. So we've spoken a little bit about kind of the data indexing side, this layer between your front end and your smart contracts and your front end hyper index. And we've spoken about it being so fast. But the question is kind of, how is it so fast? And that's because we've got something called hypersync. And the way we look at it is hypersync is the engine to hyperindex. Now, hypersync is a very optimized data lake for getting data, but we've specifically catered it to blockchain data. And usually you would use RPC to access this kind of data, but RPC is more of an afterthought and it's not really designed for large scale data needs. And so Hypersync is the engine that allows our indexing or data consumption to be extremely performant. Cool. And we'll go through some examples of that too, and we can see it in action. Maybe one more note on that. A node in its current form is generally used for it's generally designed around consensus, keeping the network alive. But it's not designed for getting data. And so we took this kind of challenge and somewhat rewrote a node from the ground up as a way of getting the data. So for example, Hypersync is similar to Node, except it doesn't perform consensus. That's not its focus. It's more around getting data. And can be extremely powerful. And we'll go through some cool, tangible examples, which I won't hold it back on much longer. All right. So I think for this call, for this session, you can kind of tag along and try play around yourself, or you can just follow the screen and we can check it out on that side. But let's get that prerequisites doc. So I've just come to the Envio docs, and here, and I just want to paste this into the chat. If it'll let me, let's see. Not allowed. All right. I saw. Cool. I'll just ping you. I can't. All right. Not a problem. Can't share links. So maybe. There we go. Quicker than me. Cool. Cool. So let's assume we've got these prerequisites. We've got Node.js. We've got PNPM. We've got Docker Desktop. Sick. Awesome. Let's go on to kind of the next step. So what I want to do, and we've got lots of different data we can look at indexing. But let's say you're developing your smart contracts and you want to start kind of indexing that data. You can work locally and stuff like that, but we've got this really nice feature called contract import, and it's going to allow me to essentially just pass in an address, and we can spin up a boilerplate, and we can look at that and unpack what that looks like. Cool. So let's jump into the code. So what I do have here, let's just go straight to the home page. If we look in the Block Explorer and we want to get kind of a contractor index, we can look around here. You can see there's a bunch of transactions happening in the last block. And I think something quite interesting to index is actually the bridge. So I'm going to take this contract address and we're going to run through the process of indexing this data. We're going to get some cool ideas on how much, so we can see all the transactions, we can see all the events that are coming off of this contract. We can take a look at how many deposits there are, and we can kind of do some basic stuff around this data. So first thing I'm going to do is I'm going to make a folder to work from. You can see I did a little bit of prep before, and let's go into that folder. All right, so that's an empty folder. And I'm going to run Envio init. Let me know if the text is too small. I'll make this full screen.
I can see it.
Looks good. All right, cool.
Yeah. I also shared the link, guys, to the contract if you want to check it out as well.
Nice. Wait. All right, cool. So I'm going to call it bridge. I've already created the folder, so I'm going to do it in this current directory. We have the option of working in a few different languages, but let's work with TypeScript. Cool. And we are in the EVM space, and we're going to import the contract. One important thing. So we have a import from a block explorer, but we don't have it working with block scout at the moment. We did, but it stopped working. So we need to essentially work with an ABI, which is also very chilled and straightforward. I'm just going to come to the contract tab here, scroll down to this ABI, and I'm going to quickly make this file, ABI.json. And the ABI is just kind of the computer representation or the EVM representation of what that smart contract looks like. So I'm just going to save that file there, and I'm going to import it from a local ABI. I've just created that file. Cool. We've just put it in ABI.json, and now you can see it's looked at that ABI and it said which events do we or logs do we want to look at. I reckon let's look at all of them. Let's play around and see. Let's take a look at all the data and see what we can come up with. So I could unselect these if I wanted to, but let's take a look at all of them. Then I come over here and I search for Citrea DevNet, which was not showing
I think
it.
rather you can provide chain ID, I believe. I can type the chain ID.
I think it might complain at me. I think I might have just run this with an older version of
Yeah,
Envio, but
possibly.
it's not going to come. I'm just gonna. I'll tell you what. I'm gonna pick a random network and we're gonna update it. Cool.
We can also use the network ID, but anyways, okay.
I think the problem is it's gonna complain at me when I want to do the hypersync integration. But let's see what we got. Okay, so now it's asking me for the contract address. Let's come up here and pull this. And I'm gonna say I'm finished. I could add other contracts here too, and index multiple contracts. We could even index multi-chain across multiple networks. But for now, that is enough. Cool. I'm just gonna use my name as an API token for now. That's totally open. All right, and that's gonna spin that up. And normally we could just run indexer, but now we've got to make one change. And I just want to see what package JSON happened here. Yeah, okay, cool. So I managed to run that with an older version of Envio. No wonder it didn't. I think that's the latest version there. And Tilip, do you have the chain ID on the
Yeah,
top of
I have. It is 62298. It is
Cool.
62298.
Let's do that. 62298.
298. Yeah.
Cool. All right, so we should be set up. Usually you don't have to do that, but I used an older version of Envio before we started supporting Citrea. If there's a network that we don't support, say for example, I don't know, another network that pops up in the future and we haven't synced it yet, you can always use RPC syncing as well, but it's a lot slower. All right, and we should be able to say pnpm. Oh wait, let's just install the latest version. Cool. We should be able to say pnpm envio dev. And
Yeah,
I
by the
think
way,
this is a
yeah, you
yeah.
go. Sorry. Well, I
No,
also
no, no,
tried
please.
RPC syncing, and it doesn't still like it's still quite fast. I mean, like definitely less than half an hour, like a couple of minutes still. So it's good.
Yeah, cool.
Yeah.
I think what's quite powerful there is that we've essentially, because we've got this huge speed engine that feeds into our indexer, we've had to keep track of kind of performance things. So there's at each step of the way, as we've added more features, if we've noticed something slowing down, we've had to kind of refactor, and it's been pretty good for us to kind of dabble. But what's really nice about this bridge contract is you can see it is flying through. We've gone through 100,000 events already, and it is just enough events that it's you can see kind of the scale of it, but it's also not too many events that during the run and demonstration it takes too long to kind of finish. The biggest indexer we've seen so far, it was an interesting stress test. We didn't actually deploy one with that many ourselves. It was just under 1 billion events, and that took about 3 days to deploy. So that is a really, really chunky indexer with many different networks, many different contracts, and lots and lots and lots of transactions. Cool, but you can see that firing through. Let's look away for a second and take a look at the code a little bit. And once that's done, we'll look at the data. Cool. Actually, wait, let's just go straight to the data. We'll still get the data. It's just going to be, it won't be finished yet. So I can go to localhost 8080, and this is essentially our view into this data. And we haven't actually edited this this index ourselves. We've just used the boilerplate kind of indexer, and we can make GraphQL queries through this kind of playground here. That's how your front end would interact with it. But what we can just do is we can just browse the data a little bit. And right now, this is quite raw data. We're just looking at event-based data. That's almost done. And we can see bridge deposits, and you can see the IDs, the receipts, the timestamp when it happened, and some other cool data points. Similarly, we can look at withdrawals as well, and we can search and do some cool stuff. Just to demonstrate it to you from the UI side of things, we can see that finished. From the UI, we can search deposits on receipt and ID and check. We get a bunch of data for that. We actually got a lot of data because we didn't filter that at all. We got a huge amount, and you can still see it was under a second to query. That should have probably changed to megabits or something. But you just get the general idea of how much data we fetched in that thing. Usually you would add filters where you say like where timestamp is greater than, let's just add timestamp here. Let's remove this for now, just so we can get a random one. Cool. It's freezing because it's such a large chunk of data. Okay. We can let's take this timestamp and we can say, let's get by where it's greater than this timestamp. I notice that timestamp looks like a string. Yeah. All right. We're usually getting the same response because it's not a number type. But
Yes.
we would edit that in the code. All right. Let's take a look. Okay, cool. So that synced through about 500,000 events in about 2 minutes. Is that right? Yeah, right number of digits. And cool. So we've seen it in action now, but we haven't really answered any big questions. We've kind of just seen it spin up and run through. I think what's quite interesting to look at is starting to look at the code. And we essentially have 3 files of interest. We've looked at this config file briefly, super straightforward. We specify what events we want to index on what contract and what network and stuff like that. Pretty vanilla, pretty straightforward. Love some feedback. I think the interface is really nice, but can get some more, tell me what you think. Then we have our event handlers, and what happens is every time we receive a deposit, we process that event. We do our own logic. This is where you write your own code, and then we save it into a database. Now that database looks a little bit like this. So we can see this is the structure of our database. We were looking at the bridge deposits table. We're looking at the bridge withdrawals table. And you can kind of get an idea for what's happening there. I think what could be quite an interesting data point to look at is to see if this bridge ownership was ever transferred. So usually what I've seen in the past is you see, let's just go straight to the data tab, ownership transferred. Nope, it's never transferred. Okay, so whoever deployed it was good to know.
Yeah.
We do have the operator updated though. So the old operator, this must have happened at deployment because you can see this is the 0 address and this is the new operator. Let's save this address to come back to at some point. I think it might be interesting. Cool. We can see it's got some transactions on it. Looks like it's got a lot of transactions, to be fair.
Yeah.
But all right, let's keep that address to come back to. That's essentially the operator for the bridge. Cool.
Mhm. Yeah, cool.
All right. So we've seen the config, we've seen this schema, this is the structure of our database, and we can change this as well. Let's say if we want to have like a user table, and we can say we can give it an ID, and this will probably be its address. We can give it an address, and we can say I don't know, number of deposits. Cool. That's maybe a sensible, simple example we can do. All right, and I think where this starts to come into play, let's do that for now, is, or let's just do this in int, I'm sure it's fine, is the event handler. So the event handlers is where you actually start writing your custom logic. And this one's super simple because it's just a general boilerplate, but we've got these different events and we handle what happens when this happens. So all we're doing right now is we're saving this data point into the DB. So we're just saving that raw event data into a DB, but we can do some cool stuff such as let's do context.user. It's going to give me a red line dot set, and we can say event dot params dot recipient. Cool. That's the ID, and number of deposits is going to equal 1. Okay, this is showing me a red line because we need to run cogen, just so since we changed the schema and stuff like that, you can just run in pnpm envio dev and it'll spin that up too. But now you'll see my red error message is gone. And if we run this, we should see we now have a new table for user, and every time we get a deposit, we essentially creating a user as the recipient, as the ID, and we're not doing anything smart yet. We're just saving the number of deposits as 1. Cool. So you can see this is flying through, and we should start having some data already. So if I come over to the I might have to just refresh this. If we come over to the user table, you can see we've got all these addresses, and number of deposits is 1 because we're just writing it to 1 each time. All right, rad. So you can see there's a lot of users who have deposited several hundred times. And just kind of interesting to start kind of building your data. And you might serve this through to kind of a front end and get extra information around it. Cool. And since this is actually still indexing, that's going to keep going up, or we should see slightly different data. So if I rerun this query, now that we've had some time, the highest number was 475. Let's see if, oh, someone's gone up. It might be the same user, but you can see they've done even more deposits. So this is just kind of a basic demonstration on how you can use this indexer to get certain information. And this aggregates and saves into a database, and it means it's always available that you can serve to your front end. Cool. Are there any questions? Thanks, George. Thanks for asking anyone if they have any questions. Let's go on to the next step. We'll keep this running, and we will take a look at hypersync a little bit more. I think that's what's next on the slides. Oh, okay, cool. So so Hypersync is this engine for getting raw blockchain data, and it's the engine that feeds into Hyperindex that makes it so fast. But let's take a look at what another example of what it can be used for. So let's take a look at this. And we want to take, this is something that's built on top of Hypersync. It's a very simple tool, but you pass it in an address, you pass it in a network, and you pass it in a, thanks. You pass in, like, either you're looking at events or transactions. It needs to be a contract in order for it to have kind of events off of it. And we just get a bit of a density graph. So we can look at that. We can try analyze that behavior, or let's say level of interaction over time. So I think what's quite cool, this is still running. Let's take a look at the biggest depositor. Let's see what that looks like in terms of number of transactions over time. Cool. And before I plug it into chain density, let's just take a look at what this looks like. I think we want to look at this contract here. Let's do this. All right. Cool. So we've got this address. It doesn't look to be a contract. It looks to be an EOA. It supposedly has done 316 transactions, which is sensible given the fact that you can have multiple events per transaction.
Yeah.
And let's take a look at what that looks like. So we're going to take this user. I haven't done this already completely. It's not a contract, so I'm going to rather look at transaction density, and we're going to look at, there we go. Cool. And I'm going to submit that. And it might take a couple of seconds, but we get a event density plot of this user. So that looks pretty organic. That looks pretty natural. You can see that they went through a phase where they did these block intervals. They did a crazy amount of transactions, or in comparison to other block ranges. Super interesting. Don't usually use this to look at individual kind of users, more generally like contracts. But let's take a look at this other contract we want. This is actually a user, the operator.
Yeah.
Doesn't look to be a contract either. Okay. This has got a lot more transactions. So it's clearly an EOA funneled through some kind of code to perform these transactions. So let's take a look at what this looks like. If we refresh. It's just refresh me. Here, by the way, we can see we've also got 331 transactions, same as. Let's paste this address in here. Oh, and I didn't even realize it's a vanity address. Oh,
We use it
check
on the system transactions because we need a public key which does not have any correspondence of a private key, and like this is the kind of solution we came up with.
Okay, cool. All right. Maybe you can tell me a little bit more about this address that could explain this behavior.
Yeah.
This distribution.
Sorry?
I'm saying, so it's quite interesting to see this address and the transactions it's done. It clearly spiked over this kind of interval here. Does this interval kind of make any sense to you? What might have happened over this time?
Yeah, it's like we had our, we had more user activity around that time, around that block interval. So there might be more system transactions done on the system, and the 0x that like gets involved in these, so it's kind of natural to edit more, I would say.
Cool.
That's the initial function,
Cool.
of course. Like there might be other reasons, but this is what I have on top of my head.
Okay, rad. I think also worth noting, we actually have a larger number of transactions processed from Hypersync than BlockScout. So you can see here there's 1.145,
Mhm.
and you can see on ours we have 1.207. And there could be many different reasons why this is the case. But what's quite nice is with Hypersync, because the queries are happening so fast, you're running it over an entire data set, and it's doing the calculation live at that exact point in time. It's counting all the transactions and putting it there. Whereas often what you see with kind of block explorers or like data dashboards or stuff like that, they'll snapshot in time. I think I'm on the wrong contract. they'll snapshot it in time. So they'll kind of do these. They'll fetch aggregate data to a point in time. So I think that's what is kind of explaining that difference in data.
Yeah.
Well, I think actually Blocksky hasn't it's updated to liveliness quite as fast.
Yeah.
Cool. And then I think we can look at, so I don't think we'll have enough time to deploy something to the hosted service, but essentially you can deploy an index. I was touching on quickly. You can deploy an indexer to our hosted service, and you can have that like system running backend live on a managed service, which is quite nice. You can also self-host. It's really easy. It's quite straightforward. But the last thing I want to demo here, what am I doing? Okay, we come back to the hypersync demo. What I wanted to show you is an example of performing a hypersync query. So we've seen a little bit about what hypersync looks like from kind of a use case perspective. We've seen it's the engine that plugs into HyperIndex, kind of the indexing framework. We've seen it as a tool for plotting massive amounts of transactions and data. And this is live querying the entire like kind of data set and aggregating this into information. But let's take a look at what that kind of tangibly looks like from a user, like a developer perspective. So what is quite nice is we've got some just simple curl examples. So we can, a little bit like how you'd query an RPC, we can query up hypersync with a specific query, say, what's the data we want? Now, it's not the same interface as RPC requests. It's a lot more flexible. It kind of mirrors, because hypersync has more like data like availability, or it can serve more data. It has a different query API, which is a lot more flexible. You can dive into these docs and read more about the actual kind of querying. But for now, we're going to do the kind of simple example. It's also worth noting there's a few different clients. So if you're a Python developer, if you're a Rust developer, if you're a Go developer, there's also a Go community-driven Go client. It just makes it a bit easier to fetch these data for your application. But let's take a look at these simple curl examples, because what I can do is I can copy and paste it into the terminal, and we should be able to see some kind of data. So is there a contract or address that comes to mind for ERC20 transfers? It can be a user or can be a contract, but maybe a user makes more sense. Or should I just pull something out? We can just pull up an address. All right. So I'm going to copy this this query, and I'm just going to paste it into this editor just so I can tweak it a bit easier. But let's do that. Let's do this. So I can use the name, or I can use the chain ID for specifying the hypersync endpoint I want to hit. And we're going to do it from block 0. Cool. Now, this might look a little bit abstract. This might look a little bit weird, but I can show you what this is actually. This is just saying we want to look at the transfer event. Okay. And this Fong Kong set of hexadecimal characters might look a bit abstract, but it is just a signature of the transfer event. And this is quite a common signature, or transfer is quite a common event. So I've actually seen this before. And if we look at one of these random tokens, we should see.
We can use the Satoshi one if you want, the fourth one.
Cool, let's do that.
Yeah, so these are CTO, so it's kind of a joke we made on our own internally.
Cool, okay. So if we look at one of these transactions, we should see, so this is a transaction hash, we should see the logs, and we should see the topics we're looking for. Yeah, this is the one. Okay, so this might be an approval log or something. It's not, here's the deposit. And here you can see we've got the transfer log. So this is more the human readable version. And this is the topic 0 representation of that. Okay, so you can see this OXDDF, and we can see this OXDDF. So these are the topics or stuff we're interested in getting data for. And then this we're going to edit now. This is the address that we want to analyze. So I don't know if you have an address for me we can take a look at. But let's
We
we could
can
also
pick
just take
one.
this random.
Yeah,
Yeah.
I don't have a particular one in my mind.
Okay. You don't know someone that we could look at the address and see. Okay, well, let's take this random user because at least we know that we're gonna get at least one transaction. Okay, cool. So I take that address and yeah. We're gonna see we're actually not looking at a specific ERC20 token. We're looking at all ERC20 token transfers. So in and out of that address. So let's paste that in there. And then the data that we're going to get around it is we want to get the block number timestamp hash. We want to get the logs for it, the different topics. The data thing might make it quite. I'm going to remove this for now just because it can make it seem a bit like noise. And then we're going to get some other transaction-based data from it, like the block number, which index of that transaction, the hash from to value input. Okay, cool. So we have our curl query. Let's stop that and let's take a look at what we get. Okay, so that user has done a lot because there's a big text dump of transactions. If we actually look at that user, this should somewhat align with, so their token transfers are 50 plus. They don't actually show it in how many they've done, but you can see they've got a lot.
Yeah.
So yeah. And yeah, this blurb of information, obviously in the terminal, it's not very nice to read, is essentially we're getting all the transactions in and out of what that looks like. So you can use hypersyncable block explorers. You can do quite a lot of nifty stuff. Cool. I think that pretty much sums up everything I wanted to cover. If there are any other questions, we're happy to answer now. Otherwise, we can to wrap up.
Yeah. Sorry, my brother's making noise. Does anyone have any questions? If not, I have just my 2 cents. So, like you can see in this demo, like then I'm pretty much went over like many details that can be done, manually for developers. But like in case you wonder, for example, you can just set up Envio and then sync with Citrea based on documentations. And then you can just open GPT-4, for example, and then you can also use it to query some data. One way to do this is like, can you open the GraphQL dashboard, Daniel?
Yeah, 100%.
Yeah. And from there, you have the data section on top, and using the data section, you can just get any event and get it in the form of the CSVs. And these CSVs are like, huge chunk of data that you can download quickly. And yeah, if you click export data, that's either CSV or JSON. And the thing is, like, these data are pretty much like in a compact form. So you can download multiple of them and then just give them to ChatGPT or any kind of application you use. And then they can pretty easily generate you graphs using the Python if they have a code interpreter. For example, I just made this one really quickly on my local. So this is just sharing on the chat. I just gave it the CSV data, JSON data, and asked it to, generate a graph. And like you can, since this is raw data, which can be put in the form of NumPy or Pandas or whatever library you use in Python, you can just make it and like, give it a shot. So like Envio pretty much enables you to do all of these, even if you're not, you're new into the space. But if you're, a cool developer, just use it. It will help you a lot. That's just my 2 cents.
Awesome. Yeah, really cool to see that graph.
Yeah. Any questions? Anyone? Anything particular regarding Citrea, regarding Envio? We will have our testnet coming in the let's say next weeks. You'll see when things happen. But we're pretty excited and also pretty happy to have Envio on board. If you have any questions, just come to our Discord and then ask us, like on the dev chat or general chat, and we'll be happy to answer all of these. Yeah, that's all on my end as well. If you have anything to add, Denon.
Cool, everyone. Thanks so much. Really appreciate it.
Yeah, thanks guys. Thanks for listening. Hope you guys a great day and a great week as well. And see you all in the next days, next weeks for the testnet and for the future of Bitcoin. Let's say.
Cheers,
Bye bye,
everyone.
guys. Yeah, see you guys. Bye bye. We will also one second. We will also share this one in YouTube as well, and also like we may share a guide later on how to do these things in a compact form in a documentation. You may also check it as well. Yeah, but if you want to see a detail later on, you can check out our YouTube channel, and we will also share the link. Yeah, I guess that's all now. So see you all. See you guys.
Cheers, everyone.
Bye bye.
Bye.